This is Geometry, Unit 4. We're working on the second day of the triangle sum theorem. What we're recognizing here is that the exterior angle, the angle on the outside of a triangle that is extended through, is going to be equal to the two angle values that are non-adjacent to it. So angle 1 is going to equal the measurement of angle A plus angle B. So the measure of the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent, the ones not next to it, but the other two interior angles. We know that the inside of the triangle adds up to 180. We know that the linear pair adds up to 180. So if we eliminate this angle, we come up with A and B that are going to equal angle 1. So let's come over here to example number 1. We're going to use this idea. We notice we have an exterior angle, and we have our measurements of the non-adjacent interior angles. So we're going to have 3x minus 9. The exterior angle is going to equal the two angles that are on the inside. From here we go through the algebra. We're going to move our x across. Then we're going to add the 9 across. Added across is going to give us 82. So I'll rewrite that since I ran out of room. So we would need to divide by 2. That gives us 41 for our angle A. We're supposed to find the measurement of angle DCB. DCB, that is this exterior angle. So we need to say that 3 times 41, not including the 9, the 123 minus the 9 is going to be 114 degrees. That's the measurement of angle DCB. This next equation, we have to draw our own picture and label it in. So angle ABC, that is 47. Angle CAB equals x minus 3. And angle ACD equals 7x minus 4. So maybe the first thing we think about is how three angles inside the triangle add up to 180. Three angles inside the triangle, but I don't have all three angles, so that's not going to help. Oh, but I have this exterior angle, and I've learned that the exterior angle is going to equal the two angles that are not next to it. So x minus 3 and 47 are going to add up to equal 7x minus 4. So we group our like terms together. We could move our x across. And move our 4 across. And then divide to get the x all by itself. And x is going to be 8. we see that we're supposed to be calculating the measurement of BAC. So I come back to figure out what is BAC. BAC is x minus 3. The measurement of angle BAC equals x minus 3. If x is 8, then BAC is 5 degrees. It doesn't really look like 5 degrees, but if you go back and check your work, that's what the calculations show us. So that is going to be 5 degrees. We look at our next example. When we look at this example, we see the two arrows, and the arrows are parallel lines. So if we're going to see parallel lines in the problem, we need to be looking for these 4 angles. Which one of these 4 angles are we working with? Well, we have a pair of parallel lines. That would be these two. And now we've got to come up with a transversal. We have a transversal here, but we also have a transversal here. So sometimes you've got to take a shot at looking in more than one location for a number. Corresponding angles would be the 43 and the number on the outside, and we don't have those numbers. That's not even in the picture, so that's out. Alternate interior, that's going to be the 43 and the x. Oh, that makes a zigzag shape. There's our answer. So x is going to be 43. If lines are parallel, then alternate interior angles are congruent. So x is going to be 43. And then we can come back and look at our triangle, and we see that 75 is the angle on the outside. Therefore, it has to equal the sum of the two angles on the inside. So y is going to have to be 32 degrees. For example number 4, what do we notice? What's going to be helpful? We have one angle value, and this is the angle for. It's not a degree value, it's an angle for. Just a quick way to name the angle. That's angle 4. We need to come up with this, but if we know that that's 50, what else do we know about this picture? We see that we have tick marks inside of this triangle. These tick marks are telling us that those angles have to be the exact same size. So I know that I have x plus the 50 that are adding all together to equal 180 degrees, which when I combine the x's together, I get 2x plus 50 that add together to be 180. So you keep thinking about what the next steps would be. We would subtract 50 from both sides of our equal sign. So we get 2x to equal 130. So when we divide by 2, x is going to be 65. So x has to be 65. 65 plus 65 plus 50 adds up to 180. That's the interior angles. Then we know that the measurement of angle 4 is going to be the 65 and the 50. So that's going to be 115. We see two right angles. If two lines, these two lines, if two lines are perpendicular to the same line, then they are parallel to each other. You could also notice that the right angles are 90 degrees and corresponding angles are congruent, so the lines are parallel. So that's going to then allow us to see our F shape There's our F shape, which are corresponding angles. So the measurement of angle 1 is 50 degrees. So for our next example, we see again we have an exterior angle. We have two non-adjacent, it's not next to it, so it's the non-adjacent interior angles. And we have learned that the exterior angle is going to equal the sum of the non-adjacent interior angles. So we're going to distribute. So then we can subtract. Move the 8 across to get 42. So 42 is our x value. So that means our exterior angle is going to be 42 plus 4, which is 46, times 2, which sounds like 92. So 242 plus 4, so 2 times 46, that's 80 and 12, so 92. That is the measurement of our exterior angle. Next, we're going to talk about a corollary. That's just a statement that's built off of a theorem. So this corollary talks about the acute angles of a right triangle. The acute angles are angles A and B. You have a right triangle, so angle C is your right angle. Angle A and angle B are your acute angles. They're going to have a special relationship inside of a right triangle. A and B are going to add up to be 90 degrees. So then you have 90 plus the extra 90 that makes the 180. And two angles that add up to 90 are considered to be complementary. So the acute angles of a right triangle are complementary. That means they're going to add up to be 90 degrees. This is just a shortcut. Many times we don't have to use this shortcut. We can kind of do it a longer method. But this is a shortcut method that's going to help. So we flip over to the other side. And I see that we have a right triangle. Well, if I have a right triangle, I know that the measurement of angle A plus the measurement of angle B, the two acute angles, they're going to add up to be 90 degrees. If angle A is 22 then I can subtract that 22 and figure out that the measurement of angle B is 68. That is 68 degrees. We look at this next example. The next example is definitely tougher than the next two. So you've really got to look at this and try to figure out what you're going to pay attention to. If you separate this down and only look at part of the picture, you look at the 25-degree angle, the y value, and this 85, just look at that part of the figure. We know that the 85 is the exterior angle, and y plus 25 are the non-adjacent interior. So we can see right away that y is going to be 60 degrees. Then we're going to look at our other triangle. If this is 90 on the outside, it's going to be 90 on the inside, so we have a 90-degree angle there. We have y, which is 60 degrees, and we have x up here. So that's going to be our acute angles of a right triangle. What do we know about the acute angles of a right triangle? The acute angles are going to add up to be 90 degrees. They're always complementary. So x plus 60 are going to add up to equal 90. We can figure out what x is by subtracting over our 60 to get 30 degrees. So now we have figured out what angle y was and what angle x was. We have a right triangle, and the acute angles are going to be complementary. They're going to add up to be 90 degrees. So the two acute angles add up to 90. We have 9x, and the 3's cross out. So x is going to be x is going to be 10. We have the same storyline here, where x plus 12 and the 52 are the acute angles of a right triangle. Together, that adds up to be 64. So when you minus the 64 across, we end up getting 26 degrees. X is not a degree. X is a value. The degree is going to be 26 plus 12. We can see I worked through some of the problem here that angle 1 is 70. Angle 2 would be 65 because 65 and the 45 add up to be your exterior, the non-adjacent exterior angles. Actually, they're interior. And then the three angles add up to be 180.